I have the from from these questions, I think I can like because I can ask you, right, for the questions that I don't know.
Right,
So if I'm confused and it appears like in the future paper, I know how to do it.
right,
I
right.
think that's why I like the how hard it is, but sometimes it gets quite annoying as well. Yeah.
It is annoying. Aiden, I can see you, yeah? Give us some time. It is annoying, but it is not, how do I say, desperating. What's the word? What's the word? It doesn't make you desperate lah,
Uh,
or give up in that sense.
I mean, like, I'm gonna be honest. If I didn't have the tuition, I think I would have given up on the paper because we don't know how to the concept. The concept was not like
Right,
fully.
right.
Yeah.
In that sense, I mean, no, that's fine. There's nothing, well, there's nothing wrong in that, right? The tuition, you are, people have tuition for many reasons. One of the reason is what you say lah, you cannot learn enough from class, whatever
Mm,
reason. But you don't mind learning. Maybe I'll say that you don't mind learning. So, and anyway, the exam is not gonna get easier, right?
yeah.
Anyway, right? So walah lo, walah tuition is helping you learn, right? Which
Mm,
in our understanding here, Joshua and Aiden, will also help you understand a bit more in class, which is why we're doing future topics right now, right?
yeah.
In a full sense, but in a sense that it will give you an ability to absorb more lah in your class. At the very least, have something to do in class lah, huh? Rather than just, while the time lah, right? Sometimes pretend to understand. I don't want you to pretend that you understand in class. You are too smart for that, right?
Mm,
So all what you're saying is true, and that's great. So we focus on the positive of your physics class law, that if they give us an exercise, we do it together lah, I suppose, right? Together, will definitely have good benefits. And I don't have to think about giving you too many more practices for physics. Actually, I don't think so. It's really pretty much quite enough lah, to me lah, for the purposes of exam. Mm, I see. I see. So that's physics, lah. Yeah, that's physics. Okay.
yeah.
Okay. This is here first, so we'll save the review for later. Yeah. Okay. Okay. So Aiden, just to check, can you hear me?
Yeah, I can hear.
All right. Wonderful. Okay. Waiting for Andrew's audio. Okay, Andrew, can you hear me?
Hello.
All right. Yes, we can hear
Yes.
you. Okay. So just in case the connection goes bad, meaning, for example, the audio is not very clear, don't suffer that, but just tell me, I'm not hearing you very well, that kind of thing, right? We're going to cover, I think, a new topic for everybody. So I have to speak more than usual, but you will also have to respond more than usual, right? Joshua, I decided for today, we're going to continue with the energy work power. You already have introduction to that. I have to give the introduction to Andrew and Aiden quickly, lah. All right, Joshua. So
Okay.
in the meantime, you still have something to do, right, from your homework, lah.
Uh,
Is that correct?
I think I can do chemistry. Oh,
Sure. Yeah, yeah.
yeah.
Do whatever you want, right? But I think in less than half an hour, I will call you and you'll join us, lah, at the same
Okay.
time.
Sure, sure.
Sure. Yeah. So for you, Aiden and Andrew, unless there is a great objection, today I want to talk about the future chapter of physics, very, very near future chapter after pressure. That will be called energy work power. That is as far as I want to talk. And this chapter is the same as every other chapter that I want to talk to you. It is always the chapter that is foundational. It is always a chapter that other chapter will need or use one. Those kind of chapters, the kind of chapter that cannot afford to not understand because the effect is, across multiple chapters. It's not, however, a very difficult one. So I think one session is definitely enough, which is this section. If there is any other objection, please tell me right now. Okay, now if there is none, I will share my screen. We'll catch up with where Joshua is. Joshua had some introduction yesterday, so I want you guys to catch up with him, and then we can do things together, right? Okay, I'm sharing my screen. It's just easier at first. Please wait for a while. Right, Joshua, to make life easy for a while, I'll be using your Jamboard, from yesterday.
Yep, sure.
Okay, right. So Andrew and Aiden, to confirm, you can see my screen, yeah?
Yeah.
Okay, Andrew? Andrew?
Oh, yes, I can see it.
Okay, right. So try not to be muted for a while. We'll have to discuss quite intensely. I haven't shared this Jamboard with you guys, so you don't worry about writing stuff for now, yeah? Now, the topic is energy work power. Sorry. Energy work power. Whatever those things means, a few things you already understand. I'll tell you what you already understand. GPE, gravitational potential energy, and kinetic energy. Both of you should know the formula they introduced to you already. So Aiden, what's the formula for GPE?
MGH.
Right. And what's the formula for KE, Andrew?
Half times mv squared.
So the important thing here is, for now, we focus on speed, which is your velocity here, and the height, right? Mass will always be there, and we don't usually consider something mass to change. So the mass is constant, the g is constant, half is constant, square is there, but the height of an object and the velocity of an object do change. We pay attention to those things, right? If you have not done that, from now on, you do that. Paying attention to the height much more than the mass or g. Paying attention to the speed much more than the mass, right? I'll give you one more thing to help us, right? In the question, an energy power question is kind of easy to recognize. It is always an object either moving up, moving horizontal, or moving down. Sometimes in this kind of manner. Right? The more chaotic the movement, the more likely is an energy work power thing. The more straightforward the movement, energy work power from now on can go in. They will try to do that one. They kind of like energy work power. So I'm going to give you something to make sense of things, right? I'm going to use money, right? So this is your wallet. Your case is what is in your wallet. Your GPE is, I would like to say, your bank account, right? Surprise me, Andrew and Aiden, do you have your own bank account?
Yes.
Oh, you do? Wonderful. How about you, Aiden?
Yeah, I have.
Right. Since both of you have your own bank account, I'll put it that way. Your bank account is different from your wallet. Let me confirm one more thing, Aiden and Andrew. Can you, pay by PayWave? As in, do you have a debit card that you can tap around one?
No. I don't.
Do you pay your EasyLink by tapping your phone?
No.
No. So you cannot tap stuff. You still most of the time buy stuff using cash. Let me confirm that.
Yes.
So Aiden and Andrew, the way for you to access your bank account, how can you do it right now? Can you access it by putting your card into the ATM and, you know, pressing your PIN and then taking the cash out? Can you do that?
For me, no. For me, it's only to the parent.
Good. I like those account even better, right? I like those account better. You may not like it though, right? But you know, how about you, Eden?
It's also with my parents.
Good. So the only way you can withdraw is, you know, through your parents, right? As far as you can tell though, you can tell this, I don't think your parent withdraw from a bank account. I think your parents usually put in stuff into your account, isn't it? Okay. They also put in stuff into your wallet, right? So we'll put it this way. There's an environment. Environment will be other stuff beside your bank account and your wallet. You have to pretend for a while that you can transfer from your bank account into your wallet. You have to pretend for a while. You have to pretend that. I'll call that a transfer. You can also pretend with me for a while that you can do the other way. You can go from your wallet into your bank account. Now, what you know is that from your environment, including your parents, things can go into your bank account. That is within your experience, right? There's also the environment where your wallet will transfer stuff into the environment. You experience that every day. Am I correct, Aiden and Andrew?
Oh, yes.
Yeah.
Right. Very rarely the environment transfer to your wallet, right? Very rarely, right?
Yeah.
Correct, yeah. But wallet serves its purpose because, you know, it's there and we want to spend our money. There's nothing wrong with that, right? Yeah, I'll stop commenting there now. But however, all this transfer of money have a very good analogy to our topic lah. Now, the transfer is work. That is what they call work in the chapter. The energy itself, the joule, is within the bank account or the wallet or the environment. Remember, your wallet is your kinetic energy. Your kinetic energy is there because of speed. Your bank account is your GPE, is there because of height. The transfer itself, you must notice that the transfer is also in the form of money. So work is also in joule. But you can tell whether it is a transfer or it is a money inside your wallet. You'll see very soon later what I mean, right? So that's energy. That's work. And power is something very simple. Power is simply energy or work divided by time. That's the easiest to understand. You will see again later what they are used for. I want to mainly talk about energy and work. Now, time for me to introduce the new formula, right? Work, which is transfer. This is the transfer. It's done by somebody. When you transfer from your bank account to your wallet, let's pretend that you can do it. Who usually do that, Andrew?
Sorry?
Who usually transfer from your bank account to your wallet, if it can be done,
Parent.
Your parents, right? Who usually transfer from your wallet to the environment? You. Who usually transfer from the environment to your wallet?
Environment to wallet.
Yeah, sometimes money enter your wallet, right? Correct or not?
Yeah, parent.
And our parents. And who sometimes transfer from environment to bank account?
Environment to bank account.
Who usually
Workplace.
Workplace? True. But wait. Do you work? Have you money?
Yes. I stopped recently.
No problem. You have some experience beside parents which is good right? You have more experience. So sometimes your temporary bosses transfer money to you to your bank account. Yes, correct. He's the one doing the transfer. My point is, Aiden and Andrew, the transfer doesn't just happen once. Somebody does the transfer, right? There's no automatic transfer, right? Yeah, I won't complicate stuff. So the somebody will be a force. Remember, work is transfer, work is the transfer. So somebody will be the force. Let me give you an example. Remember that our gravity potential energy is our bank account. Our KE is the wallet. When GPE transfer to KE, it is when something drops, right? Something drops. Your GPE here is high, your GPE here is low, right? Your KE here will be high, your original KE will be low. Who does the transfer? Very simple. It must be one of the forces affecting him. In this case, as weird as it sounds, who's the force doing the transfer, Aiden? For
The
something
force
happening? Yep.
is the environment.
I'll keep. Why is something dropping?
Plus gravity.
Correct. And gravity is a force, right?
Yeah.
The transfer between GPE to KE is because of, well, a force, the guy doing the transfer. And that will be your gravity. That will be your gravity. Okay. So in this case, the gravity is doing work. What do I mean by, I'm sorry, I should share. The gravity is doing work, meaning when they say that, it simply means the gravity is the one doing the transfer. Transfer of what? Or transfer within one form of energy to another form of energy, from your bank account to your wallet, for example. Somebody must do the transfer. Gravity in this case must be the one doing that. They will keep saying this phrase one. Something does work. Something does work. I'm trying to make you understand what it means right now. Now, before I continue, any question, Aiden and Andrew?
No.
No.
Right. So the formula is complete by doing this. This is the transfer. This is the guy doing the transfer. There's always one every time. And then this is the distance where the transfer is done. The longer the distance, the more transfer you can do. Meaning, at this point, if this is longer, the GPE will be lower, the KE will be higher. Okay, I'm going to state the obvious. If you transfer $500 from your bank account to your wallet, your bank account will reduce 500, your wallet will increase 500. Cannot be not like that one. It cannot be 500 and then here 501. It cannot be 500 and 499. Okay, at the risk of being obvious. Yeah. Now, here's another example. Then we can go to a question already. Something is traveling with a speed. Okay, what kind of energy does he have initially, Andrew?
The initially speed initially.
Yeah, if he has speed, I want you to automatically, therefore he has a certain form of energy. What would that be?
Kinetic energy.
Very good. That's what you know, and you need to pair them up in your mind. Right? Oh, speed adalah kinetic energy lah. Simple. Or height or gravitational potential energy. Quite simple. Now, this thing is moving straight, not up or not down, right? But suddenly at the sun, somehow he stopped. The kinetic energy is obviously now 0. Andrew, what happened to the money in the wallet? What happened?
It goes into the environment.
Right, there must be a transfer. There must have been a transfer. The transfer is kind of a gradual and all along until there is no more money to transfer and, well, we stop. Now, what force is doing the transfer?
Friction.
Very good. That's it. Look. So in this case, the work done by the friction, meaning the transfer of energy, right, is done by the friction to the environment. So we are transferring from kinetic energy to another form called heat. Right? I'm trying to impress upon you, Aiden and Andrew, that you seem to already understand this chapter. I seem to just be adding new words, right? It seems to be something that you know already. That is the impression I'm trying to create. Any question, Andrew and Aiden?
No, so far, no.
Andrew? Agent, sorry. I'm gonna give you. No, that's not that. Wait. So now Aiden and Andrew, using your own paper, try to do this question. Try to do this question. The blue one is done by somebody else, right? There's no guarantee that that person is right or wrong. Okay. The person say the answer is D. Be careful. That person may be right. That person might be wrong. Okay. Joshua, can I help you so far?
Hold on.
Mhm.
Oh, okay.
Andrew and Joshua, just to confirm, Andrew and Aiden, just to confirm, you can still see your Jamboard, yeah? Can still, yeah?
Yeah.
Okay, good. So I didn't, because I'm going to do something. If you cannot see it, you tell me immediately, yeah?
Do you need me to use a new Jamboard if I have any questions, or?
We can go in the old one. I can do that. I can let them see the other page while I still,
Yeah.
see the other page with you. So maybe we go to page 16, right, Joshua? Yeah.
Yep.
Okay. Okay. Right. Okay. Tell me, what's your question, Joshua? Atom economy.
How do I process this? How do I start?
Right. Okay. Right.
How does this work?
Right. I'm not fully sure what he's talking about, but I can guess lah. I can guess.
Let me take a screenshot of the top.
I'm not sure why this is useful though.
Sorry. Here you go.
Yeah. You
At the top here.
put in stuff. Yeah, you put in stuff. Okay, so he's saying something very simple, Joshua. The MR of usual product and MR of product, right? So he's just focusing on the right hand side. First thing first. There's always one or more than one thing in the right hand side, right?
Okay.
For when you do a reaction, it's usually it's more than one. It's rarely for you to have a reaction we simply produce one final product. There is usually more than one. You're probably more like used to it without questioning why. But that's, I guess, that's just mostly how things work. Okay. Sometimes there will be 3 items, sometimes there are 2, and very rarely there will be 1. So far, so good.
Okay.
So when you say MR of usual product, he's telling you that you don't usually want all of the product. You usually just want one. That's your goal or your subjective meaning. Meaning the reaction has to happen like that. The reaction has to give you more than one thing, but I just want one of the things usually. In this case, he's saying that I want the fertilizer, this complicated looking thing.
Oh, okay.
In that sense,
okay, then
this reaction, only produce that guy. Oh, atom economy 100%, meaning, 100% of the product is useful to you. For the other one, you don't just say 1/2, you must calculate the MR. He proposes that you use the MR. So fine, I calculate this MR, that MR this over total, I will have my atom economy. That's just what it means.
Okay.
Okay, so nothing very new, I would say. Just one way to use MR. Okay,
Okay.
back to Andrew and Aiden first. Andrew and Aiden, how are you so far?
I think that the person answer is wrong.
Noted, I won't reveal first what I think, right? If he is wrong, however, and you have good reasons, you should, I don't know, you should do more than him, or you should do something different than him.
I feel like I think he's wrong because it only takes into account GPE but not the KE.
I would definitely agree with you that he should take account your bank account and your wallet cannot just be one of them lah. I agree with you lah. That one I agree with you. But can you do better work than him? Give it a try for a while. And what do you think, Andrew? Where are you so far? Because I stopped seeing your video. I cannot see your video, right? Okay, yeah.
I'm still, just working through it.
Very good.
May I ask for MG
Yes, I cannot hear you. Yes, you're saying.
or MGH, the height I just use SI unit. Sorry.
SI. The safest thing is to use
So,
SI lah, right?
1 meter lah.
Meter lah. Yeah. In this case, all the unit are SI, so that's one less problem to worry about.
Okay.
Yeah. Tell me when you're stuck or when you're done, Aiden. If you can continue, do.
And is it C?
I don't think so, Aiden. Of course, I would like to explain to you, but still waiting for Andrew. I don't think so, however, Aiden. I don't think so.
Because like 2.8 and 5.6, right? They put 2.5. So like you cannot like get that the 0.8 and 0.6 from anywhere in the question.
Can. Yesterday we did it together and we get something else other than C and D lah. We did. It's between A or B lo.
Oh.
We did. At least there's an answer lah. At least lah.
But then if I use common sense, it's A.
At this point, if I say A is right, then B is wrong, or then okay, I get your final answer. Say now, wait for Andrew first. Andrew, do you have your final answer, or are you stuck, or what?
I don't have my final answer yet. I'm still trying to think through it.
Yeah, think through it a bit. Just give a bit of time, Aiden. In this starting point, we wait for a while. Afterwards, you guys can go. I'll give you more questions. But this time,
actually, I think it's B, 5.6.
All right. So Aiden, now you change your answer to B, right? B. I don't know why, because I cannot follow your working for now, but we'll see later, right? So Andrew, maybe 2 more minutes, then we'll start discussing. Okay, we'll wait for a while. Almost half an hour, so almost on time.
I think I'm stuck. Could you explain it first? Then I think I'll get it better.
Yes.
Thank you.
All right. I'll use the bank account wallet thingy. Hopefully that is more useful. If it is confusing, you tell me immediately. Now, the person doing this question talks about his bank account. Initial bank account, $20. This is the bank account at B, the GPE lah. It's 28. So you have an increase in your bank account by $8. Aiden and Andrew, agree with this first?
Yeah. And that
yes.
$8 come from KE, right?
It must come from somewhere. It must come from somewhere. And if you say it comes from KE, that you should see a drop in KE, look, correct?
Yeah.
Okay, so let's see whether that's true or not. So Andrew, have you calculated the initial KE?
Yes, 16 newtons.
Right. So not Newton, but joule. Remember, energy.
Sorry.
So we call it $16, Ken. So KE at A, 16 joule or dollar. Final KE, Aiden?
Final KE is like 1.
Andrew, agree with that?
Yes, same.
Half times 2 times 1 square, right? I agree. So you see your bank account increased by $8. You see your wallet drop by $15. In general, just to confirm this, Andrew, if that happens to you, Andrew and Aiden, will you be happy or unhappy?
But why is it? Like my wallet?
Your wallet decreased by $15, correct?
Yeah.
Your bank account increased by $8. In
Then
total, you're happy or not?
you won't be happy. Also,
Yeah, because
that,
you lost.
the amount of money lost is the friction.
Correct. So there's a loss of $7 lah. Correct. We can see that lah. We can see both. That's what makes us unhappy. And you say by friction, agree with you, there must be a transfer from, in this case, your wallet to the bank account and your wallet to the environment. There must be lah.
Then 7 divided by 2.5, right?
Yeah, 7 divided by 2.5 lah. So in this case, the work done is $7, 7 joule. Can you accept that, Andrew? That is the work done by the friction. No? The amount transfer lah. The transfer from wallet to environment must be $7.
About that. Okay.
Because from 15, 8 goes to the bank account, right? Okay, so left 7 lah, right? So the culprit is friction. So there you go, friction. I'll call it FF. And then the distance is 2.5 meters. So when you press calculator, what is 7 divided by 2.5?
It's 2.8, which is A.
Yeah, which is A lah, which is A. So that's just the frictional force, look, the strength of the guy doing the transfer, 2.8 lah, 2.8. Andrew and Aiden, do you understand what's going on?
Yeah, I can understand.
Right. Let me ask you one question. Why did we use 2.5, not 2.4?
2.5, not what?
This is 2.5, right? They tell you us the total distance between A and B is 2.5. Why did we use 2.5, not 2.4? Look, there's a 2.4 here. Drop of 1, up 1.
Oh, because you're trying to see the position where the box is moving along, like the path it's taking. Like, but the vertical height isn't the path.
I agree with you. I hope that is okay, Andrew. We should focus on where the guy is working. That means where the guy is doing the transfer. The guy is not doing the transfer vertically up and vertically down, but along the path. So we use this.
Got it.
Okay. So, and that basically covers most of the topic load, meaning now it's time to jump into questions. Meaning, yeah. So I'll go get one. I'll go get a question. Wait. Joshua, any question to settle so far?
I think I can do the rest myself.
Okay, all right.
Yeah.
So physics. There you go. Oops. Press the wrong thing. Sorry, I'm pressing the wrong thing. Oh, there you go. Got it. Okay. Share. Okay, yeah. So at the start, I tell you, Joshua, Aiden, and Andrew, it's kind of easy to identify the energy work power question. So let's try to do that. Okay, let's choose a random school. Joshua, choose for us a random school. You can see in the screen, right? You can, right?
Yeah, I can see. Bartley.
Okay, Go to Bartley SA2. Let's do that. Okay, everybody can see this. Okay, let's start from MCQ first. If you see what you think is a energy work power question, you stop me, right? Okay, anything so far?
No,
Okay. Anything so far?
no.
Oh my God. Well, surprisingly, 5 can be done without that. So fine, fair enough. Fair enough.
That's pressure, right? Is it pressure?
That's balance, moment, balance. That's balance, moment, right? Would you guess that 11 is energy work power? Would you have guessed that? Would you have guessed?
I think they mentioned height and then distance, so I think that could be like the
That's a
what gave it away. Yeah.
what gives it away. But can we do this with the kinematics?
It's
Question mark.
Pythagoras theorem, is it?
Pythagoras theorem. Would you need Pythagoras theorem? A question mark, because this is the first time you see something moving up a slide. Maybe.
We don't have Pythagoras though.
Let's give it a try. Let's give it a try. I am sure that this is a what do you call it, the topic, but let's see whether our knowledge is enough. I'm so sorry, wrong page. So can you guys see the Jamboard? Wait, might be doing all the wrong things, right? Yep, now I can see this. Okay, now I'm giving you annotation, guys. So in case you want to write something, we'll use annotation for a while. Yeah? Annotation means not Jamboard, right? Annotation means directly on the Zoom. Make our life easier. Okay, now let me repeat to you what I think is the best way to approach this. I evaluate, I think about the bank account, I think about the wallet, and I think about what happened to them. Okay, that's what I think, right? No matter what the question is. Let's see, yeah. Oh goodness me, right? Ooh, this is. Turns out that in this question, I want to think about the transfer from the environment first. That's what I think, right? So this pull and this frictional force, this pull and this frictional force.
Yeah, the resultant force is 1,200 Newton.
Right, we'll do that. So in our mind, this becomes 1,200, right? Going up, right? Yeah. Now, let's agree that this 1,200 is a guy, right? A force. And if a guy happens on the scene, he must be doing some sort of transfer. What kind of transfer? We don't know, but he must be. Let's calculate the amount of transfer first. How do we calculate the amount of transfer? By using our new formula, right? We have the guy, 1,200. Do we have the distance or the amount of transfer?
Yeah, force on distance is 1,200 times 25.
So we have 25. So everybody, please tell me, this is the amount transferred. What is it?
It's 3,000.
No, it's 30,000, I think. Please check one more time. Check one more time. Andrew, to confirm, 3,000 or 30,000?
It's 30,000.
30,000. So this is the amount transferred. 30,000 joule or $30,000. Now, from where to where? So remember, you have your bank account, you have your wallet, and you have the environment. The transfer can be from this to this, from this to this, whatever. You tell me, people, where is the transfer coming from and to where?
It's coming from the bottom of the slope to the top of the slope.
That is how far it happens, right?
Yeah.
Which affects the distance, right? Which affects the distance, and we can use that to calculate the amount of transfer. Wow, $30,000, quite a lot. Still, is it 30,000? Let me just put it this way. Joshua, is it from bank account to wallet? Is that where the transfer is? From GPE to KPE, in short, right? Is it?
It's like, I mean, it has no height, right, on the first
No, it does not.
Oh, I think like I get the answer. It's B.
B, yeah, but please answer the initial question first lah. There are 6 ways of transfer. So where is the transfer again?
It's
Mm,
from my
G
kinetic energy to
KE
GP.
to GPE.
Okay, so Joshua say from KE to GP, right? That's the amount of transfer lah. So far so good. Okay, let me just check with the other two first. Eden and Andrew, where do you think the transfer is coming from and going to?
I think it's from kinetic energy going towards GPE as well. That is why like at the top of the slope, you calculate the MGH here, then you calculate the KE of like the thing. Then you can get the height.
I agree with both of you that GPE is increasing lah. That much is obvious, right? I
Yeah.
agree with you lah. I agree with you. Let's ask Andrew first. Andrew, what's your opinion?
Yes, the GP increases because the height increases.
Right. So GP is increasing, but are you sure it's from KE to GPE? Because there is still one more option lah. It can be from environment.
But you already eliminated the environment at the frictional force.
Are you saying that the pool is not environment?
Like the pool is the force that I am doing, so it's like me transferring it. The environment is a frictional force which has been removed already.
Now be very careful with your thinking. Now, we are concerned with the wallet and bank account of the block lah, yeah? Not with us lah, yeah? You are correct to say that obviously somebody is pulling it lah. It's just that we don't draw it out lah, right? Now, that somebody pulling the block. It's not the block, okay? It's not the block. That somebody is doing work lah. That somebody, if it is not the block, it is not the bank account and it is not the wallet of the block lah. It is part of the environment of the block. Makes sense. This need to make sense first. It's not drawn there. The person is not drawn there, but there must be somebody doing it.
Yeah, so it's the environment because it's external to the diagram.
To the block, right? Now, further, wait, Andrew, what do you think about this?
I just agree.
Okay, for now, yeah. So here's another option. Now, both this option means GP increase. Let's investigate whether KE decreases or not. Remember, if there's a transfer from KE to GPE, GPE increase, but KE decrease lah. Now, is there any sign that KE here and KE here is, well, decreasing?
KE isn't decreasing.
Because they don't tell you anything about the speed, right? That can be good, that can be bad, but we just take it that the speed doesn't change, no? Because they never tell us what. It's an assumption, yeah, based on what they are not telling us. Fair enough? It is like, it is an assumption, right? So if you assume that, then we cannot agree on this transfer. This transfer makes it more likely, no? It must be from somebody else to your bank account, which happens all the time, right? It's from your parents to your bank account. I hope that makes some sense. Okay, it does happen all the time. Okay, so now given all that whatever so we know the transfer already is 30,000. So how does that help us figure out the increase of the increase in the vertical height? What do we do?
You calculate GPE.
Increase of GPE
is MGH, so it's basically 5,000 Newton times the height, and you sub in the height as 6.0 meter, you get 30,000 joules as well. And since it's the same, then it means that B is the answer.
Correct. So for now, simple, that's 6 meter already. Okay.
Yeah.
Would that be okay, Andrew and Joshua?
Yes.
Right. So far, not very difficult. So far, not very difficult. So let's find another question and see whether you can do it yourself, right? Now, is this? Okay, fine. So I guess this qualifies as an answer, right? Anyway, this is exam level, so it's good for you to have a feel, right? So I'm putting in the Jamboard right now. Okay. Right. Give you 2 minutes. Give me some answers. Joshua, okay?
Oh, good.
Andrew, okay?
Yes.
Aiden, okay?
Is it D, Ken?
You have an answer. We'll keep it there. Right?
Yeah, but is it D or not? Because like it has a lighter score, but when I calculate GPE, I don't know is it correct lah. It's MGH, then I get 4 joules, and 4 joules is like 4 meters, so it just like goes all the way down.
I mean, I agree with you that it's 4 joule. That much I can say. I cannot reveal the right or wrong first, right? But this is definitely 4 joule of GPE lah, at the start. That much I can say you are correct, right?
But I might be wrong because I thought that was a sandpit. I thought the 4 meter height was a sandpit.
No, the center is below, right?
Yeah. Also, I just calculate the GPE for all of them, and then I see which one has the highest GPE.
That's one way of doing it, I suppose. There is definitely one way of doing it.
Like then it's C lah, Jake.
So we have another answer here. So Joshua, do you have some final answer?
Because Jake has the highest GPE, so like it's gonna like has the most joules, and then it hits the sand with the most joules, then it should go the deepest.
Now, Joshua?
Yeah, I agree because I calculated it and I got 4.5 joules. And then Daryl and Kent only has 4 joules and Alan only has 3. So the one with the greatest GPE will have like the will sink the most basically. Yeah, it's C.
So Andrew, what do you think?
Yes, got the same answer as the both of them.
At this point, I also agree with all of you. So either we are all right or we are all wrong, right? But for now, I think we all agree. I don't think the question is complicated in any other way lah. I don't think so lah. So I think that will be correct. Okay. Okay. Wow. Exam level not so difficult, right? Are you seeing the screen? Okay. I keep messing up the screen sharing. Right? I keep doing that. Okay. There you go. Right. So just to confirm, for those who are learning pressure, you know this is pressure lah. This is no longer the question, right? So I'm going to skip. The moment you go into pressure, they will all talk about other different topics already. So let's see what happened in paper 2 lah. Okay, this is, I don't think, the energy work power. This is also not energy work power. This is pressure, this is pressure, this is heat, this is heat, this is light, this is electricity. So it seems we don't have any other GPE question again, right? Yeah? So it seems. Oh. Okay, let's see. Can you do this? Not very complicated, I would say. Okay, going to the Jamboard. Now, please try to do this. If you have a question to clarify, please clarify. Right? Don't suffer by yourself. This is not exam, right? You discuss if you don't understand certain things about the question.
Like, what's the mass of the ball?
Do they give you the mass of the ball, right?
Like,
Question.
oh yeah, they did.
Be careful with the reading, but you're right to ask that lah. They should be giving you that, right?
It is 7.2.
Write down first.
Because on the ground there is no GPE. Because height is 0, then GPE is completely 0. So you just calculate that at B, right?
No comments on that first lah, but I'll write down your final answer. So there you go.
Wait, do I do the questions below or just the first one?
Oh no, everything. It's not. It's probably not very complicated.
Is it 9.7 for the second one?
Don't know, but I'll write it down. 9.7. And there's part 3 lah. There's also part 3. Yeah. Just to confirm, Joshua and Andrew, are you okay or are you stuck somewhere?
I'm okay.
Andrew?
Yes, I'm good.
Oh, the second one may not be 9.7.
What is it then?
Like, I know it's not 9.7 lah, because like the third one is 9.7, is it?
I mean, the third one is speed though, so be careful.
Oh. Oh, then I use 9.7 and find velocity, is it?
You can do that if 9.7 is KE lah.
And then I'll get some fun, like long number. Is the answer like long number or like short?
If it's ugly, don't worry too much about it lah. Ugly, just say ugly lah.
Like if I were to use, like if I were to error carry forward, then it's like 20.763.
20 20.7. Really? Meter per
20.8 if it's 3SF.
meter per second. You sure about it? Okay. Not all but you're right though. The mass is so small, then the velocity will be bigger. No, you're right. The mass is so small. That might make sense. That does make sense.
Mm.
So, Joshua, where are you?
This part. I just finished the last part. It's 20.8, by the way, because you have to round it up.
Around there, huh?
Mm.
So I take it that your answer in part 1 and part 2 is similar.
I got the same
Right.
answer as him.
My answer should also be 20.8 because it's rounded up as well.
So Andrew, how is it?
I'm still doing.
Give more. Right. Now, in that case, that means let's look at one more paper. Andrew, I do want you to take your time. I do want you, especially when we're learning at the start, we cannot be rushed. We cannot. Right? I'm not asking you to match the speed of the others. That's not what I'm asking. Now, let's go.
Isn't this a set 2 topic?
No. We'll try one more. While waiting, we'll try one. That's the better way. And this MCQ though. Oh, that's great. This is harder. Okay, this is for while waiting. Oh, sorry, I do it wrongly. I should have put it here. For your information, Joshua and Aiden, because I'm asking you to do this question, right? This question has some measurement in it. Right? Has some measurement in it. There's always one question like this at the end. So they always want to have a question which has some sort of measurement, either graph or table and whatnot. Now, so happens that this measurement question is also energy work power. So happens they take turn one. So don't be surprised that you have to kind of read the measurement to figure out what's going on. Don't be surprised. So that does take some time. Okay. Now you do that while we are waiting. This is slightly harder lah.
Is it 12544 joules?
I'm sorry.
Oh, never mind.
Don't be too fast. Don't be too fast. I won't answer your question one. At least not at the start. But I will record your answer. Now, Andrew, are you okay so far?
Almost done. Got the second part already. Just the.
Okay.
Yes, I got the answer. It's the same.
Oh, then my answer for the new question is 39.2.
Okay, wait, let me write down. Jule, right? In this case,
Yeah.
Now let's talk about the first question first. Okay. So Andrew, let me confirm that is your answer the same or different?
The same.
Right. So let me just do a very quick check. I mean, there's nothing complicated to this line. This is 60 meters. So 105. And if that is what gives you 7.2, then everybody, you are correct, right?
Yeah.
At B, kinetic energy of the ball is 2.5. Kinetic energy of the ball at A. Right. So since the GPE goes up, the KE must have gone down lah. But in this case, this is 2.5 plus 7.2. That will give you correct? Because this is just a transfer between your wallet to your bank account, okay, from A to B lah. So the speed of the golf ball just before it lands at C. So now let's see what you do here lah. I will have to have the KE at C loh. I believe the KE at C will be
9.7.
7 also lah, 9.7 joule, and then this will be equal to half mv square, right? So
Yeah.
9.7 times 2 divided by 0.045 lah, right? And then square rooted will be your v. If that's what you do, then you will be correct. Okay, guys, so far so good.
Yeah.
Now this is a year
Yes.
4 question. It's a year 4 like a prelim question. Whether you find it easy or not, I hope you'll be able to benefit from this question. Okay, right. So there isn't much else to cover from this topic. When you discuss it with your teacher, I hope your teacher will give you maybe 1 or 2 challenging questions. In general, this topic is not very challenging one. I just want to make it very clear, right? Sometimes, even though it is easy, some of my students cannot seem to think clearly. So I'm not very happy with that. Just want to clear that for now.
Yeah, my teacher isn't teaching this topic.
Isn't like he's going to skip.
He said like self-revision.
I mean, admittedly, it is not as hard as the rest lah, but we'll see lah. We'll see what happens. Right? Okay. So I will leave this topic to the class law. When we talk about topic in the future, we never covered fully. We just cover all the essential stuff. We did cover all the essential stuff already, right? So we are gonna put the next question on hold lah, and I will put it out when we need to lah. Now we still have half an hour. In this case, we have an option. Andrew. Sorry, before I close the topic, I'm so sorry. Anything else to clarify? Aiden, Joshua, and Andrew regarding this topic?
Is this topic just GPE and KE and that's all?
No, GPE, KE, and the environment. GPE and KE is secondary 2, from primary 5 to secondary 2. Now there will be friction. That means this question in front of you, the golf ball one, is considered quite easy because you don't have to worry about the environment. That's why it is easy.
Oh.
I'm a bit surprised, but that's what they give you in a prelim. So I mean, anyway, the topic, yeah. So the things which will be difficult is the one that involves friction, changing GPE, and changing KE. So 3 things changing. I haven't seen that for a while. Okay, to answer your question, you're asking something, Joshua? Not okay. Is it okay?
All good for me.
All right. Anything to clarify, Andrew?
No.
Right. So you'll probably find more questions as you do them more, right? Hopefully your teacher will give. If not, I will certainly give you nearer to exam, right? Okay. So now at this point, we'll revise. We'll see where we are right now. Okay, we'll see where we are right now. Right? So the goal I present to all of you is that we should stabilize our term 3. Stabilize our term 3 so that when we enter term 3, we can understand the subjects better. So let's see where we are in doing that. Sure. So for physics, there's the past topics. Then there is pressure, and then there is a work, energy, power, right?
Yeah.
For discussion purposes, all of you are done here. For pressure, Joshua, I think, can consider done. Let me just confirm for Aiden and Andrew, pressure consider not yet, correct?
Almost done.
You did it with me.
Almost done. Oh, Andrew, you're almost done, really? In the school?
I should be.
Oh.
I think the teacher said she's gonna move on.
Oh, no, that's not what I
Next
mean. No, that's not what I mean by that. I mean, how good are you in pressure? I know Joshua.
Okay, then no.
Okay, all right. So question, I'll put it as a question mark first. Aiden, correct, right? We just started pressure talking, right? We haven't.
Oh,
we haven't done
I
much.
mean, my teacher has completed that, but you just started that.
Yeah, you get my point, yeah. So both of you are around at the same level, maybe around medium, right? Okay, understand, right? So and then for chemistry, we talk about the mole chapter.
Yeah, but the thing that I need to do for chemistry is my teacher isn't going through ammonia because when I don't know the because last week I mentioned to you that the change of class thing.
Correct.
Yeah, because your topic pacing is different. My new teacher has done a qualitative analysis. No, my new teacher hasn't done qualitative analysis, but has done ammonia already. But my old teacher has done qualitative analysis, but not ammonia.
So here's ammonia and here's QA. So Aiden, if I'm correct, your teacher has done ammonia. Your new teacher has done ammonia in other classes, right?
Yeah.
Your whole class is moving to your new teacher, right? It's the whole class, right? Correct.
No.
Or not?
No.
Only you.
Yeah.
Huh?
Yeah.
I'm very confused. Oh, my headache. Right. Okay. My headache. Okay, your QA is around there, right? Your QA is around there. Your ammonia is a bit in jeopardy because your teacher say they won't be discussing, right? Your mole is quite done and your acid-base solubility is done, correct?
Yeah.
Okay. Andrew, tell me, how are you in this 4? And Joshua, you think?
More here haven't started yet.
Yeah. And mole is a bit somewhere right now, right? Acid-base solubility.
I'm not good at acid-base solubility.
Yeah.
I'm okay with moles though, I think.
How about you, Andrew?
Acid-base solubility also okay only.
Okay. Both of you shouldn't have covered ammonia. I don't think so, yeah?
No.
Okay, ammonia is usually at the last one, so it's a bit unique. However, Andrew, since you belong in the same school, then ammonia is probably nearer than what I would expect. Just for your information, some schools cover ammonia after Sec 3 end of year. It's a topic that they throw around one. It's a bit weird for me, Aiden. So I'm definitely noting that. It's very weird. Right? Let me confirm that QA, Joshua, not yet.
QA not yet, and ammonia not yet. Acid and bases not yet. We just touched it, like with you. I just touched it. The topic.
Right. Confirm. Okay, I understand now. Andrew, your QA done or not?
QA. I don't think so.
Right. Okay. If you know you have if you have done it, you have known one. Right. So here's the solution, Aiden. Later at my okay. Because Andrew and Joshua is busier and you have more lesson than them this holiday, so no problem. No, there's no problem there. We'll cover ammonia. I'm planning to cover ammonia with you, okay, later on. Then you have some peace of mind. Would that be okay? Later. So that you don't feel it's so bad. Right now, yeah, this is a bit challenging, isn't it? No, it's not challenging. We have time. When we have time, it's not challenging now. Okay, Joshua, tomorrow we'll talk about acid, base, and solubility. Okay?
Okay, I'm okay with that. Okay.
Right now, you finish all your physics stuff. So your physics is very strong entering term 3 lah. Your chemistry is a bit iffy lah. Just a bit, okay?
Iffy, yeah.
So that's still not bad, right? We'll do that. But right now, you just continue with your physics law.
Okay.
You can ask me questions. All right, I'm gonna stop the screen sharing, Aiden. We're gonna go for pressure lah, Andrew and Aiden. Yeah. All right. So what?
Can I join in actually? Just like for. Because I think I just need to.
No, their pressure is very basic.
Oh, okay. All right. Okay.
Yeah, you'll be bored. But
okay.
that's because you do all the good stuff already, right? Okay, so don't worry about that, right? Okay, wait, I'm gonna take a picture on this. Let me send it to social media. Okay. Okay. Wait. I'm preparing the pressure Jamboard. Just wait for a while. Please wait for 2 minutes. Okay, so Aiden, I'm going to ask you to join in Andrew's Jamboard for a while in case you need to write something. But most of the time, just look at the screen, one same thing. Yeah. So Aiden. Okay, now I'm sharing my screen again, and you will see it. So Andrew and Aiden, you will be paying attention to the screen sharing. And for Joshua, I will be paying attention to your Jamboard. Okay. So Andrew and okay. So let me confirm. Andrew and Aiden, both of you have discussed this question. It's not a very complicated one.
Yes.
Yeah. Andrew, Aiden also, yeah. Right.
Yeah.
So, you correct me for a while, Aiden. Have we discussed this one?
Yeah, we've talked about this.
Right. Okay. So now let's move on from there. I'll give you something slightly harder lah. Okay. Now we have something new. Oh wait, loading is a bit long. Okay, so you're gonna ignore the other people's working for now. It's a bit blurry. If there's something blur, you help me. You ask me. Yeah, you ask me. Okay. Please read the question. Let's discuss about it a bit, and then if you can, you do.
I mean,
Yes, Aiden, you're saying.
which question? Which question?
Oh, do you see something in your screen sharing? You do, right? Yeah, you do. So the
Yeah,
question you see in
This
front of
one, we've talked about it before.
are you wait, are you sure?
Yeah, you can see my Jamboard because my Jamboard has that as well.
Oh, we have talked about this already. Wait, we have talked about this? This is the gas thingy, right? When you exchange the first cylinder to the second cylinder?
Yeah, this one was the one where I asked you something like how does 0.05 turn into 500?
Oh, we did. You're right. No, you're right. Something else here. Please wait for a while, Aiden. Let me do something for you. Okay, got it. There's another one. Okay, please think about the other one. Aiden, thank you for telling me. Joshua, are you okay so far?
Yeah.
Are you putting anything for me to see?
Not yet, no.
Right, so Andrew, right, let's talk about the big question, yeah? You didn't talk about the small one, right? Okay. Andrew, what do you think about the big question so far? How are you? Andrew, can you hear me? Andrew,
Yes, I can. Sorry,
what do you think about that question?
can't read it.
Okay, okay.
Sorry.
I forgot about like the pressure thingy.
Yeah, how about you, Aiden?
I forgot about the pressure thing. Like,
The unit, is it?
no, I
Oh,
mean like how to do question 23, like the understanding I forgot of like pressure.
let me refresh you. This one is a very weird question, yeah. Your glass tube is usually not horizontal. We don't usually use the glass tube horizontally, and we also don't let air trap below one. Usually the air is trapped above. So this is a bit weird and definitely not the usual thing. And maybe that's why you feel it's a bit weird. However, the principle is extremely extremely similar, right? Look at this mercury. Who is pushing this mercury?
The atmospheric pressure.
Okay, from the outside lah. I'll take it from the outside.
Yeah, the inside is also pushing it.
So in what direction is the atmospheric pressure pressuring?
It is going from the right to the left.
I'll put it this way. That's atmosphere, right?
Yeah.
The trap air inside?
The trap air inside is pushing it outside. It's pushing to the right, basically.
Something like that. And that's basically what you need. That's basically what you need. For diagram 2, the atmosphere is pushing it how?
The atmospheric is pushing it down.
Fair enough, right? And then the air is pushing it.
So it's the same thing.
I don't think so. I really don't think so. So you think again. I think. But once you think like this, you at least have an answer already. Right?
But why is it 63?
The answer is not guaranteed one. Never think that the answer in front of you is the same. It's just the answer of somebody else. Ignore it. Ignore it. That's not the answer key. That's not the answer key.
But then it's the answer D.
You have chosen D, right?
Yeah, because at diagram 1, there's no gravity. Is gravity involved?
Well, I mean, gravity is pushing down. In this case, probably we can ignore it in diagram 1.
Like in diagram 1,
right? Probably we can ignore it in diagram 1. Right?
Yeah, is it the same in both areas?
Let me put it another way. I think your D is correct. Diagram 2 is because the trap air has to resist the mercury weight also. He has to resist atmospheric pressure. He also has to resist the mercury. So there's an increase in the pressure. The 87 happens to be 75 plus 12. So that feels about right.
Oh, so D is correct.
I would think so also.
But why is it plus 12?
Because the mercury pressure is 12 centimeter Hg. That's the unit that they use. If you don't understand this unit, you tell me immediately. Uh-oh.
I thought you said mercury was like 13.6 or something.
Oh.
Like 13.6.
You better. Okay, both of us better. Okay, all of us better understand this. Okay, wait. So Andrew, you are still reading the question?
Oh, it's a bit blur.
Oh, it's difficult to read. That's what you're saying.
Yeah, sorry, that was difficult. Yeah, I was saying that.
Understand? No, you must tell me. No, must tell me if you're facing such a difficulty, right?
Okay.
Don't stop and Okay. But before that, I'm going to take you to another page. I'm going to take both of you to another page. I'm going to discuss what this unit means. Okay. Okay. So let me show you something now. Okay, this is the new unit that is supposed to be very useful, but it ends up being confusing to most people. I don't want you to be confused, right? Let me draw a simpler. Joshua, are you okay so far? Joshua, are you okay? I cannot hear you, Joshua. Joshua, are you okay? Joshua, are you there?
Yeah,
Joshua,
I think I'm okay.
Aiden, you can hear me, right? Joshua, you're not hearing me, is it?
Sorry, I went to the toilet earlier.
Oh, you okay?
Yep, I'm okay.
So now Andrew and Aiden present. So this is mercury, and this is vacuum, and of course there's an atmosphere here. Now you tell me, is this possible or not?
That's not
No.
possible.
No.
It's not possible. Now tell me why is it not possible?
Atmospheric pressure.
So what will atmospheric pressure do actually?
It will
Uh,
push the water at both sides of the tube, and then when it pushes the water, it will go up to the vacuum, the tube in the center.
Now in this case, it's not water, but it is mercury, right? The difference you'll see later. Why? So it'll push it up. Let's say until here. Now tell me, Andrew and Aiden, why does it stop here?
Because there is, vacuum means there's no air. Right?
So why does it stop here, for example?
because at that point, the column of mercury applies the same pressure as the atmospheric pressure.
So the atmosphere is doing this, right? And then the mercury is also doing this, and this is pushing it in the same force or pressure. So therefore, we are now stable. We are equilibrium. Okay.
Oh,
So that would be the explanation. Aiden, you okay so far?
so this is like a tube like that as well.
Oh, it is a glass tube. Yes. This kind of thing is always a glass tube, I guess. Right. I guess. If that doesn't make sense, you tell me. You tell me first.
Yeah, it makes sense.
Yeah. Something is a voice in. Why? Aiden, Joshua, and Andrew, you tell me whether you're hearing other voices.
I'm hearing other voices.
I'm also hearing other voices. Joshua and Aiden, are you? Oh, now it's stopping already.
I
Okay.
think it's from me.
Right.
Yeah.
It's okay. Stop. Right. Okay, so now Aiden and Andrew, here's the question. I add more Hg. I add more Hg such that therefore the Hg level is just slightly above, right? Okay, this is I add.
Yeah.
Now, what will happen? Tell me.
Nothing will happen. I mean, the water level will stay the same, right?
That's the question. I believe that is the question. So you're saying that nothing will happen to this. That's what you're saying, right? Nothing will happen. Okay, how about you, Andrew?
Nothing. Same thing.
I mean, like maybe it will increase a bit, but the increase is like negligible because it's like 2 less.
Right. So I'll put it this way first so that there's no doubt. The Hg that we add does add by a significant, but significant means, let's say 1 centimeter. Let's say 1 centimeter. 1 centimeter is reasonably significant, right?
Yeah.
Now, what happens when we add 1 centimeter of Hg outside? Nothing happened. Slight increase, but negligible, or what?
If you add 1 cm outside, does it mean like there'll be more force to push it into the tube?
I guess we can analyze it this way, Andrew and Eden. If I see it from here now, right? I see it from here now. So the atmosphere will now act here, right? Instead of the old height, correct now?
Yeah.
The old height is here, so atmosphere is now here. And the one to balance it from inside is this amount, which is affected by this amount of height, right? So what do you think? What do you think?
Then the magnitude of the force inside the tube is smaller, is it?
Correct. Because the available height to fight, right? The available height to fight is now shorter.
Oh, so you don't need as much water inside.
No, you need more. You need more. Let me put it this way. Yeah, let me put it this way. So again, Andrew. So they always say that the atmospheric pressure, they always say like this. Atmospheric pressure is 1 bar, one atmosphere, and 1.01 then times 5 Pascal. Imagine that there are already 3 units already for pressure, and then they go and add 2 more. Crazy people, right? So 76 centimeter Hg, which is a unit of pressure, equivalent to 760 millimeter Hg. Please don't be confused. This is really centimeter, and therefore millimeter is 760. Just consider these two to be, almost the same. But to be complete, you have 5 units of pressure to deal with. That seems to be very annoying and unnecessary, right? But there you go. You have 76 centimeter or 760 millimeter Hg. Sometimes it's 75, sometimes it's 750. Don't know, whatever. Here, I will use 76. In the original, therefore, this is your 76 centimeter of Hg, right? By the way, that's what the unit means. 76 centimeter Hg simply means 76 centimeter of Hg lah,
What is Hg?
against the pressure of atmosphere. You're saying, Andrew? Sorry.
I didn't say anything. Sorry.
Oh, sorry. So, okay, yeah. So that was the original height. Now, when you add the Hg, you have now an increase in the height. Therefore, the atmosphere will not act here. And therefore, this is the thing. And suddenly, if nothing happens, you have 75 centimeter of Hg fighting against atmosphere. Okay.
Yeah.
But the atmosphere is 76 still. So let me repeat the question. What should happen?
Just now you said that it will increase.
I hope I didn't spoil the answer. So again, what will happen? The pressure from inside is now smaller than the pressure from outside. Do you agree or not, Andrew and Aiden?
Yeah.
The pressure from outside is 76, but the pressure from inside is only 75. So what should happen? The guy in the outside should push
The guy inwards higher.
a little bit here. Until how? Well, until 76. Until 76. So this increase of blue of 1 centimeter is not because we added inside directly. That's not what it means, but it's because, again, the pressure outside pushing it in a little bit. Then you get
So the pressure outside wants to be the same as the pressure inside.
If not, that's what I'm training you. If not, what will happen? He will push in. Correct or not? It's not that he wants to be inside. No. A pressure just want to push one. Very simple, right? If he has the chance to push, he push low. If the inside is 75 and outside is 76, the 76 just want to push lah. Until where? Well, until the inside can fight him off. Keeping it simple. The pressure do not want to equalize. The pressure wants to push. Some other pressure should be stopping him. Something like that.
Oh, so they're not trying to be equal, but they are equal.
They just naturally equalize, because then, so to speak, nothing can happen.
Oh, so if like my outside increase to like 80, my inside also increases to 80.
Must be because the outside will push against the guy inside. Until, but at the same time, when he pushes in, he increases the pressure inside, because he pushes the liquid in. So by the act of pushing in, he's increasing the pressure inside, and therefore, after a while, the pressure inside is big enough to, well, equalize with him, and then nothing will happen.
And the pressure inside is rho GH, right?
Do you notice for a while? It is true that it's rho GH. There's nothing wrong with rho GH, focusing on the H, right? Do you notice that all of us are just talking about the H until now? Outside is 76 centimeter, so inside should also be 76 centimeter. Why do we just talk about the H? Because like MGH, the M don't really change, the G don't really change. Rho GH is not MGH, sorry, it's not. But rho GH, the rho don't usually really change. The G don't usually really change. Who changes?
The H.
The H. So we just talk about the H. In the same way we talk about GPE using MGH, is the same way we talk about H in pressure erosion. Just the H. The H is what matters most of the time. Now, this is what the unit means. This unit means if you want to find out the pressure, really, you go and put it in rho GH. But physicists take shortcut, just talk about the H. Simple. That's what the unit means.
Oh,
Now, I have to clarify. Aiden, Andrew?
the H is this thing.
The H is, well, the height of the liquid. I mean, the height of the liquid, which can push. In this case, pushing against the pressure from outside. In this case,
But is the H from here until here, or like from here until the bottom one?
right? Then let me ask you a question again, which is a very good question. Yeah. So now, if you take this plane, right? Basically, that's what you're saying, man. Then you measure this. Oh wait, this is a lot higher. This is 80. I mean, I agree with you, right? I agree with you. That's 80. But don't forget, here you have the atmosphere here, which is 76, and also another 4. I mean, if you take this plane, you don't get something for free because the other guy also have some liquid here. Do you understand or not, Aiden?
Why is this 4?
Because this is 80, man. 80 means you drop down by 4, man. Correct?
Oh, but I thought 76 is the pressure. This one is the height one. This one is height, then this one is pressure. Then why are they like together?
The 4 is the 4 of the Hg, right? So what is the pressure of 4 centimeter Hg?
What do you mean by pressure of 4 centimeter Hg?
It is. Andrew, are you okay so far?
Yes, I get it.
Yeah. So let me try one more time, because time is almost up. If we don't get this, we'll talk about it again. This is so very important. Right? So I know that the height is 76. I know 76 centimeters, right?
Yeah.
So to keep it simple, the pressure here due to 76 centimeter is pressure A. Pressure A is 76 centimeter of Hg.
Oh, so pressure equals height.
No. In the equation of pressure, rho GH, only height matters. So when I say it's 76 centimeter Hg, if you really want to be precise, what I mean is you first of all have to take the rho of Hg, 13,000, 13,600, right? 30,600 times G times 0.76 meter, right? Now, this is the real pressure if you really want to. This will be in Pascal. But taking a shortcut, I just call it 76 centimeter of Hg, and everybody hopefully understand. Oh, that's the pressure caused by 76 of Hg. That's what it means.
So Hg is just a representation of Pg.
The rho,
Like
the rho. Hg is mercury. Hg is mercury. 76 centimeter of mercury, you put the mercury in the rho.
And then if it's not mercury, it's not Hg.
For example, it can be water. It can be water. So 76 centimeter of H2O. Totally fine.
Oh, this is just a chemical symbol.
Well, I mean, Hg is the chemical symbol. You don't. Hg is the chemical symbol, the periodic table symbol of mercury. It is. Oh, goodness me. I'm sorry. I haven't mentioned that. Yes, that is the chemical symbol of mercury. It is.
Oh.
Andrew, are you okay so far? Andrew, are you okay so far? Yeah. So 76 centimeter of H2O, I'm going to ask both of you, are they the same with 76 centimeter of Hg? Same or not?
It's not the same, right? Because like this is 13.6.
Yeah, it's so far off. It's really so far off. because one of them is 1,000 for the row, the other one is 13,600 for the row. They are so far off. So the Hg and the H2O matters.
Oh,
The H2O really matters. The water is almost nothing compared to Hg because Hg is so dense. In that sense. So one more time, when I speak in 76 centimeter, obviously 76 centimeter is not the pressure. Obviously, it's just the height. However, the pressure is due to 76 centimeter of height of Hg. I mean, that's the shortcut. Will this be okay?
oh. So when I want to find the height, I just find like where this dot is, this dot here.
To be fair, the dot here, let's call this B, the pressure there is not 76 centimeter Hg lah. It's not that. It's whatever this height is lah. Whatever lah.
Okay.
Makes sense? And then there's a C here. Let's say there's C. So let's say they tell you that the pressure here is 80 centimeter Hg. They tell you, hey, that means this is 80 centimeter. That means lah. What else could it be? That's what it means lah.
But above this dot is not tube.
I mean, does it matter? Above this dot is 4 centimeter plus atmospheric pressure. Don't forget there's atmospheric pressure, you know. Don't forget that. What is the atmospheric pressure?
76.
Correct? 76 centimeter Hg because of atmosphere, not because of Hg, but the amount of pressure by the atmosphere is equivalent to 76 centimeter of Hg, equivalent.
Oh, so
Yeah.
the atmospheric pressure is the same as the height.
I mean, the height of the mercury, don't you think? The
Yeah.
height of the mercury gives you the pressure of the atmosphere. What else is he giving you? He must be giving you that. That's all his.
It gives the pressure of air, like up here.
I mean, let me put it very clearly. Right? Let me put it very clearly to you. Let me show you Hg equivalent to H2O is how many, right? You press your calculator for me. 76 times 13.6. Could you please press this calculator? You tell me. Joshua, sorry, a bit long. Are you okay so far?
Yep, I'm okay so far.
Because it's 1.5 hour, you feel free to stay around, or you want to see me tomorrow, that's also okay. Right?
Okay.
Just feel free. Okay.
Uh,
You and Aiden, we're gonna stop after we talk about. Yes, Joshua, you're saying?
can I go? Okay. Thank you.
Andrew and Aiden, you give me this value. What is it? Calculator.
It's 1033.6.
From there, Andrew.
Oh, yes.
Right. So now let me tell you something. 76 centimeter Hg is equivalent to how many centimeter of H2O? 1033.6 centimeter. Just to be clear, this is 10 meter of H2O. Now, why am I telling you this? If I use water, I have to have a glass tube of 10 meter height. You know how high 10 meter is? 10 meter is 3-story, 3 levels. Your house times 3 meters. So I need to have a glass tube as high as 10 meter, 3-story, 3 houses to balance the atmosphere. First of all, therefore, I don't like to use water. I like to use Hg. So I like to express my atmosphere in terms of how many centimeter Hg does it need to fight off the atmosphere. If I state it in water, you wouldn't believe me unless I show you. Unfortunately, I will not show you both. This is unfortunate, but I will need 10 meter of H2O. Now, can I express an atmosphere in terms of how many meter of air? Air in this case will be, can I put this as oxygen? Atmosphere is actually how many centimeter of O2. Can I actually do that if I want to, Aiden and Andrew?
You can, right?
I can. Definitely I can one. Because to be fair, air is oxygen and nitrogen. So maybe, oxygen plus nitrogen, whatever. We can do that. We can do that. Andrew, would you make a guess how many meter of air would that be, the atmosphere?
Sorry, for what?
How many meter of air is the atmosphere?
How many meters of air
That
is
makes
the
sense.
atmosphere?
Yes.
Yeah,
How many meters of
gas.
is above us?
Gas.
That means air is not just around us, it's above us, right?
Yes, it's
How
above
many
us.
meter? How many meter would that be if you may guess?
Do I Google or do I just guess?
Oh, yes, no, just guess. Just
Okay, about 100,000 meters.
100,000 meter. Oh, actually, oh, okay. This is the first time. This is the first time somebody guesses more than 100,000, right? Okay, which is around 100 kilometer, right? The rough answer is around 30 kilometer. Roughly lah, that's roughly 30 kilometer. So this is the first time I see.
Okay,
Yes, more. It's fine.
that's an over guess.
Never mind. We will never know lah. Have we ever jumped to 30 kilometer? We never, right? Okay. The highest mountain is only 8 kilometer. Now, my point is this, Aiden and Andrew, if you can accept this, 30 kilometer of air, which is oxygen and nitrogen, is balanced by only 76 centimeter of Hg, because Hg is so dense, mercury, and air is, well, so not dense, right? That's what we expect out of air. It is not very dense, we can walk through it. So the pressure of 30 kilometer of air is equivalent to 76 centimeter of Hg. We never bother about this value. We just call it the pressure of atmosphere. We never really bother. That's why I have to ask Andrew to guess. We don't want to bother also. No need. We just want to bother with things that we can measure. It's very difficult to measure 30 kilometer, you see. It's extremely difficult. Mercury is our shortcut to measure the atmosphere in a more reasonable way. Even water is not very reasonable. 10 meter is not very fun to measure. It's really not very fun at all. I'm not sure whether I'm answering your question, Eden. I'm not sure. I'm trying my best. Am I answering something that your mind has?
Yeah, I guess so.
Roughly, yeah, roughly. Andrew, I'm not losing you in any way.
No.
Then let me ask you one more time. In this point C, right? Point C is here. Point C here is 80 centimeter Hg. Obviously, this is 80 centimeter, even though this is only 4 centimeter. Does this confuse any of you?
The 80 cm Hg at the bottom doesn't equals to the atmospheric pressure, right?
No, the atmosphere is 76, remember? It's established here one. The atmosphere has always been 76 because this is 76, correct? This is the point where atmosphere fights 76.
Oh, so atmospheric pressure is from A, not from C.
Why would it be C? Because in C is atmosphere plus a bit more. That's not atmosphere.
Oh.
Right? There is atmosphere, no problem, but don't forget this, don't forget that. That counts what? That really counts what? Correct. Mercury is so dense that it must count. If this is air, 4 centimeter, maybe I'll pretend that it doesn't exist, but this is mercury, what? So to speak. Will that make some sense, Andrew and Eden?
Yeah, it does.
Yeah. So back to the question. Why am I talking about this? No, I'm not. I'm trying to explain the unit. The unit centimeter Hg, far from being something confusing, should be something useful. I am trying my best to help you use it that way, because once it is useful, you'll be a very happy person in the pressure chapter. If you don't like that unit, you'll be a very miserable person in that chapter. It's almost like that. It's almost like that. Now, I'm not asking you to be happy right now. I'm asking you work with me. You'll see from the questions later on whether that unit is the useful one or not. I am claiming that they are the most useful one. Okay, I'm trying my best to help you. Now, we are over 15 minutes for Andrew, and we still have 15 minutes for Aiden, because Aiden, you're trying for 2 hours, right? Let me confirm this one more time. Aiden, you feel okay so far? We are almost at 2 hours. Are you tired?
I wasn't trying for 2 hours. I thought it's 1.5 and then 1.5.
Hey, you told me this week you want to try 2 hours, man. You remember you told me one what?
Yeah, I told you, but then like the concentration is like a bit, yeah.
Which is what I want to know lah. Which is what I want to know lah. Yeah. So this concentration is a little bit dropping, isn't it?
Yeah.
Okay. Then Andrew, how do you feel right now? This is more than 1.5 hours.
Yeah, same as Aiden. A bit
Okay. We don't
losing
push here, but
focus.
yeah, because when I push more here, I'm pushing towards something even harder. Not a good idea. Correct. We'll stop here for now, Eden. Andrew, this is also a good information for me because there is a probability that I need to increase it in 2 hours next term, depending on your class situation. You see, so it's good for me to handle or not. Right now, we stop at 1 hour 45. Okay.
Yeah. Okay.
Andrew, I'll see you tomorrow, and Aiden, I'll see you tonight. Okay.
Okay.
Okay. Bye bye.